Awesome. So let me go ahead and get started here on, agentic architecture, especially in production workloads and how that looks when you need to scale, etc. So as she said before, I'm a developer advocate at ClickHouse. For those of you not familiar, we'll get into what ClickHouse is, but basically I've been working within the database space for over 6+ years, and I'm a big fan of open source databases. I know for most people at this conference and in the room, you deal obviously with a lot more with cloud, a little bit less open source, or if you're dealing with open source, it's for HIPAA and security compliance, but I honestly just love the fact that we're open source, which allows quite a lot of our enterprise customers actually to take advantage and push in code that they need for their own workloads. It is a huge flex. So AI architecture. So these are going to be the three things that we're going to kind of go into, which is how our customers use ClickHouse to power their current AI tooling. This will kind of go over a little bit of different parts of the AI stack, because there are different AI architectures, if we're being honest. There's things like observability, there's things like vector search, there's just all different types of workloads. Building your own chat agent, or building our own chat agent, putting our money where our mouth is what I like to call it. It's when we built our own internal chat agent that we're using for our own business logic that we use internally, which I'll talk about. And then we also have a quote unquote front-facing version of it so that then people can actually interact with this workload, because you obviously can't interact with our internal one because that has customer data. And how you can build your own agent, which was partially built out as customers asked for it, basically. They saw what we were doing and they wanted to replicate it for themselves. So what is ClickHouse? So ClickHouse is an open source columnar OLAP database. This term means that OLAP just means analytical processing. It means the database is very good for large analytical queries versus what would be called an OLTP database, which is transactional based. That's when you do a lot of modifying and deleting. This is a very common SQL, like a PostgreSQL and MySQL, those kind of row-based databases would be common for that use case. Because of that, it is designed to be extremely fast for massive volumes of data, like what you would commonly use for AI architecture. It speaks SQL fluently. This is a huge plus because most models have been trained to write and query with SQL, not so much necessarily other query languages. It processes data very fast. It has highly efficient storage, which basically just means we have a very good compression rate and easily scalable to any size. So some of our use cases are, the most common one is real-time analytics, which we normally define as customer facing. Basically, it's the websites that you go to that you need to have your graphs or your customer facing analytics come up very fast on the screen. If you've ever used something like a Cloudflare, for example, that's being powered by ClickHouse for their visualizations. Again, applications, dashboards, etc. Basically, anytime where speed is of the essence, which is why it's called real time. Data lakes and warehousing, this is what we're talking about quite commonly at this conference in particular, which is, business data for internal use, which then you can use your BI software on top. Very similar to how you use right now your Snowflake or your Databricks, though more commonly ClickHouse lives on top of those workloads. So like imagine it like a hot layer on top of something like Snowflake or Databricks data warehousing. Observability, that one is, like DevOps, basically. It's going to be your logs, metrics, and traces, things with open telemetry, et cetera. And then machine learning and Gen AI. So that's being a feature store, a vector search, LLM observability, or AI agents. Those are kind of the big four ones. So this is kind of how ClickHouse looks when we talk about AI and ML. It hooks up to a lot of the tooling and visualizations that you take advantage of, whether that be something like LangChain or Grafana or Hex. And then it also connects up to the models and AI services. And I'm going to kind of show better visualizations of how this architecture ends up looking. But let's first go into how some of our customers use us, because it kind of paints a picture for you to better understand, basically. So first of all, why do you need real-time analytics for AI agents? So high-performance querying is very important because agents frequently basically do back-to-back querying. They're very aggressive, I guess you could say. They like to query as much as possible to get their answers. Real-time analytic databases are also built for things like those complex aggregation and fast pattern recognition. That's very important. Low latency data. AI agents often operate autonomously and require the most recent data to respond accurately. If the data that they're getting is old or outdated, it's not ideal because they'll just spit back basically hallucinations or lies. And unified data access, which is that basically they need broad context. They need to be able to access all different types of data types, from domain specific to multiple systems, and having it all in one location, very similar like a data warehouse would be, very important. So for example, DeepL uses ClickHouse to aggregate all their users' history. This data store is used for training and inference models, and even when reading tens of millions of rows, the performance was great. So this is a much better like image basically to kind of explain what some of this is, but the easiest one right here is like observability. That's just basically observing like data pipelines or AI agents as they operate. We have two big customers that I'll get into in a second on that one. Data exploration and preparation, that's really important, especially things like feature stores, which are basically a curated data set that you train models on. So this is all basically just like exploring the data that you have, prepping it up to be a model training data set, which basically just means you remove anything that you don't want the model to be trained on. Like for example, if you are building a customer facing, like if you've ever gone to nowadays like a banking website or something, you get the little annoying chatbot in the corner. That chatbot is hopefully being trained by the best uses, I guess you could say. The best way to respond to you is not being trained by like angry agent who doesn't like you. Hopefully it's being trained by the best examples, and that's kind of what they do is you need to go through your data set and you need to clean it out. Or maybe there was erroneous data. There was stuff that was just straight up wrong. Somehow it got added in. You need to get that out too. So that's kind of where these offline and feature store comes in. Same with model inference as well. And then vector store is very straightforward. That's basically just vector storage. Vectors are just embeddings. They're just basically, to me, they look like very long number sets, which is technically what they are. And basically they're stored within the database, and then from there you can query it with things like vector similarity search. So, which I kind of talked about a little bit, but basically ClickHouse has the ability to store those embedding vectors alongside your just regular structured data. That's very important because it means you don't need to have a vector database. Now, to be clear, because I get asked this question quite often, it's not that ClickHouse is a vector DB. It's just that we can and are good at storing vector embeddings. That doesn't make us a vector database. We're still a columnar, OLAP DB. We just happen to be good at the workload. And for a lot of our customers and users, they like to not have to learn, multiple databases. It's not fun. So if it works for their use case, they'll use ClickHouse as a vector DB, which is also partially why we built out our nearest neighbor search. This QR code here is actually the documentation for vector similarity search, which allows you to do similarity lookups. It also has things like high-cardinality metadata filtering in the same query as your vector search, which is useful if you're going through things that are, like user IDs, et cetera. And also column storage means that the embedding scans are dramatically faster than obviously row-oriented alternatives. And just in general, that's kind of how this works out. This is actually going to be where I mostly end talking about vector storage, because for us, it's a good use case, it is, and it's well built out and robust, but we think the agentic AI workloads are going to become even more relevant as time goes on. But this is one case study of Anthropic. So Anthropic and OpenAI both use ClickHouse for observability of their agents, of their large agent workloads that I'm sure at this point we're all relatively familiar with. But basically observability is for Claude model training in Anthropic's compute environment. So this is completely on-prem, unshockingly. This is just a nice little case study here. On the next slide, I have a nice QR code that you could scan to read the full story, but basically they needed something that could scale with all of the amount of metrics and logs data that they were receiving, which is unshocking to be sure. So basically this is just talking about how they scale with us for observability data. OpenAI is the exact same thing basically. It's just all their log data from their research, from ChatGPT, and from other API products. This is again just a bunch of stuff about their solution and how it works. And again, a really good story to take a look at how they're basically, this actually is a really funny story because it talks about also when they first released their imaging. So like back in the day, oh man, I can't remember when, but basically there was a time when everyone started making Ghibli images of their families. And this became a huge sensation online, and it basically caused like a huge crash out on the backside. And they partially used the log data that they had to figure out like scaling up, but also like what the heck was happening to a certain extent. I think it's kind of it's a fun story that they talk about in the blog. So the ClickHouse MCP server, I like to say, and in general, most people nowadays, or I shouldn't say most people, most services, most companies have an MCP protocol, or they're working on one if they don't already have one. But basically what MCP allows you to do is just link into the database and start querying from it from an agentic workload. So pretty much everyone who needs to, query with AI into a DB is going to use MCP. It's pretty common for, like I said right here, like local file access, company DB queries, et cetera, et cetera. For ours, it's built both into our open source. In fact, the open source got it first, and now it's built into the cloud. I like just showing these videos because it's just a much easier way than versus me just trying to like pull this up on my own. But basically, as you can see here, this is within like our cloud interface, but this would also look the same on the open source as well. You basically enable the MCP protocol. You grab that. And in this one, they're going to go ahead and pop it in, I think, to their own project within their code base. Here we go. So we can see this is all being built out and queried via ClickHouse via the MCP, which means they can also go ahead and chat with it. So from in here, they're saying from my data in ClickHouse, what are good investment opportunities? This one's specifically looking at pricing data from the UK pricing index. It's like a free data set that basically just talks about everything that's ever been sold in the greater British United Kingdom. Trying to think about how you word that. But as you can see here, actually, you can actually see right there that the agent itself is calling and querying like 6 queries in under a second. Like as I said before, agents tend to be a very, I call them tenacious. They're very tenacious. They like to harass your database as much as possible. And also with this one, we asked a very like straightforward question. But as you all know, whenever you've worked or talked with an agent over like a chat thing, you can ask it like 10 questions at once, and it will, for the most part, not reject you. It will normally just go answer all 10 of them. That's basically what this is doing. And it's also creating right here a visualization that you're going to see here at the end, where it basically went ahead and told you the most expensive and cheapest or whatever. This data set's really nice because it's very easy to understand, I guess you could say. It's quote unquote well built. And this is another one where I think they're going to be showing it off, within the Claude environment. So this is basically hooked up within Claude. You can just go ahead and chat with it. And to be clear here, we mostly use Anthropic and OpenAI, like ChatGPT and Claude, mostly because they're trained models for writing SQL. So that is one thing, is if you're using like a model that you built yourself or an open source model, it might not be able to write SQL queries. It might need to be trained on how to do that, versus these two products are trained on how to do that. They know how to write SQL, which is very useful because otherwise you would need to train the model on it. But to be clear, we're actually working right now internally on trying to basically use more open source models or create a training profile for you to use on your open source models, so that way then you can teach them SQL, specifically somewhat also ClickHouse SQL, which is only slightly different than regular SQL, and basically be able to take advantage of that because we've been asked to basically to do that next step. Give me a second here. I've somehow been trapped in a loop of videos. Okay, there we go. Building our own chat agent. So basically, once you have your MCP server, like I said, as a business, as a product, et cetera, you can finally start building out your chat agent. So this is something that my coworker built, which was supposed to be kind of like a funny, like in the past, this is how we used to interact with databases. And basically what they're showing here is they're making individual queries, like they're doing a select all from, and basically it's like a one and done. Like you make one query and you get one request back. And this is basically also how like the entire web is currently built. If you've ever, used a website or something, this is what's happening on the backside, give or take. I mean, sometimes some websites are querying like 10 times because they have a bunch of like visualizations or dashboards to load in. But for the most part, it is like a one and done type thing. And this is kind of what it looks like as an actual visualization. Maybe you have like a middleware layer, maybe you have like a React app on the front end or something that's dealing with the request and changing out the queries a little bit and feeding the results to the users. But overall, this is roughly how it looks. But as I said before, AI agents are quite tenacious. Basically, AI agents are powered by large language models. Those are the ones I talked about before, where you have to train them up. And from there, they can understand, decide, and act. Tools supercharged with them are great, but they are, as it says right here, they're kind of tireless, autonomous, and prolific. And so basically you end up with architecture that this is actually the architecture for this project. And basically what it is it takes ClickHouse with the MCP plus LibreChat, which I'll get into. It feeds this into users. AWS Bedrock is what's holding the actual agent. And Anthropic API, which is helping write the SQL queries. It's hooked up via LibreChat, basically. And from there, as you can see, even on this right-hand side, we're running lots of queries. We're running multiple queries as it completes some. It's running new ones as it's getting part of its answers. And basically, it starts to look a little bit more like this, especially because, keep in mind, this isn't just like a one-and-done agent. Like, it's not just your personal agent. In theory, this is an agent that multiple people can be using at the same time, which means the amount of queries is going to extrapolate up quite high. Because again, it's going to keep going and finding information. And to be candid, it's probably also repeating queries, if we're being honest. Maybe it's not being the most quote-unquote efficient. It's not really remembering things, which again, if you reloaded a website, would be exactly what happens. It normally refreshes unless, again, it's storing it within the cache or cookies or somewhere like that. It's going to go get new, fresh queries. Just imagine this at a much larger scale. And so basically what we did was we built our own internal data warehouse. or as you can tell this is by engineers because it's called Data Warehouse AI Natural Expert, and then they called it Dwayne. So we all call it by the quote unquote human name Dwayne, but that was its original like internal engineering name, and then they just like renamed it to Dwayne. I just thought that was kind of hilarious. I'm like, this is a very engineering thing to do, is to just name it that instead of something more fun or cute. It's just Dwayne, which to be fair, you know what's funny? Until I read this blog like a month or two ago, I didn't realize what the name was. Like I didn't realize the correlation because when they introduced it to the entire employees, they just called it Dwayne and didn't tell us what this actually meant on the backside. So until I was reading through the blog and I was like, oh my God, they named it what they named the internal project, basically. I thought that was really funny. And so basically, it's an internal AI assistant that has fundamentally changed how we interact with our data warehouse. I'm going to be honest, I was never really looking at the data warehouse to begin with. I'm not in the data analytics team, but apparently this is great because it empowers all of us across our company to no longer bother the people in the data analytics team because we can now just talk to Dwayne, basically. And to be clear, no one was like fired or left the job or anything like that. It was just like they now have time to not answer our horrible Slack messages. But basically what it's doing is it's using ClickHouse as the data warehouse. It has a data warehousing glossary, which is basically just a way of helping it understand what our data is, because even we're not perfect. It needs to understand some of our terminology, et cetera. It has the GitHub repo, and it has a columns directory. Basically, these are just little things that help it understand what it's looking at within the data set. This is extremely common, by the way, whenever people build something like this, is that you need to, as well named as your data set might be, you might need to give a little bit more context for your agents to understand. And then basically, again, LibreChat on the front end, Amazon Bedrock and Anthropic on the back end, internal user integrates with it. And the architecture, as it's described here, the UI layer is LibreChat, which we're going to see in a second when I show you the front-facing one. But basically, it's like it's going to feel a lot to you like ChatGPT or Claude, but it's basically a user interface that you can basically recreate your own Claude or ChatGPT for your internal data. You have your LLM provider. For us, it was Anthropic Cloud 4.0. I'm sure this is actually different at this point. The blog was like last year or something, so I bet it's a different one right now. The integration layer, that's the MCP servers. Great, super straightforward. The data warehouse is just ClickHouse Cloud. And then the documentation is the GitHub plus file system, which is, yeah, like field definitions, processing docs, and a business glossary, because you need to have these things so then the agent is empowered enough to understand what the heck it's reading when it queries from the database. So, but we needed something for the public. Like I said before, Dwayne is internal. I can look at it, but I can't show it because it's for our internal use case. It's got all kinds of people. This is actually going to show a video, but I'm just going to go to the real one right here. So this, you can even tell it's LibreChat because it has this little logo here on the side, which there we go. Let me zoom in on this. Let me make this a little bigger. There we go. So basically, Agent House has a bunch of already preloaded in data sets. So I can ask it like, what data sets do you have? Whenever I ask this question, it always gets more. So I'm always kind of excited to see. Let me check. So it's going to go ahead and running the list of databases. Got some thoughts. It's trying to format them out for me. So as you can see, these are all like open source data sets. They're all pretty like chill. Like for example, here's like the NYC one. I normally do the airplane one. I'm actually looking for it right now. I'm hoping it didn't go away. Oh no, did my airplanes go away finally? I feel like I've just lost it. But either way, I'll ask. Airplane. Yeah. Oh no, it does say it has flights. Okay. Yes, okay, great. It says it's got the on-time database containing US airline performance. Let me take a peek inside. It's getting me some, so this is literally just telling us what the table looks like. So this is basically like asking, you know, as if you were asking it in SQL. And if you actually pop this open, I know it reads kind of weird, but actually this is kind of reading a little bit strange. Normally it shows you the SQL query that it asked. I'm trying to see if it's not showing it. This is actually just showing the actual results I'm looking for. It used to show us also the SQL. I think they took it away, but it used to kind of show like what SQL queries it was actually making. Not that you would necessarily copy and paste them or anything like that, but basically it could help you understand what it's actually asking on the backside. So for example, it's giving me some recommendations here. I guess we'll just go ahead and pick one and ask it, but how much do weather delays cost travelers? Let me pull this. And this one probably is going to take a while, I would guess. Okay, yeah, there we go. That's kind of like, oh, Yep, it's just going to keep going. It's answered one question. It wants to keep going because it's like, I haven't gotten everything I wanted. Oh, that's interesting. It's also pulling from somewhere else, from like studies online. Because this one also does have access somewhat to the web. Actually, it's told me before that like I'm asking a question that it doesn't know from the internal thing, and so then it goes to the web and finds something for me. As you can see, it's now doing another query because it wants to visualize something here. Basically, it's just going to keep on chatting to me, and then there it goes to build it out, actually. And this is from LibreChat. That's how this front end is being built. If you give it, I wonder if we can see anything in the preview. Yeah, we can start to see this being built on the preview as the code finishes up. The preview will get more and more intense. It looks like it's already done the shell, and now it just needs to add the graphs. Yep, there it goes on the bar charts. I've done this before a few times. I always ask different queries, though, because I never remember what I've asked in the past. But I do remember that it always does a visualization normally for me. We'll come back to this as it continues to code in the background. But basically, this is the quote-unquote front-facing version. So that's also what this is showing as well. It's just showing the video of this. So Agent House eventually turned into what I like to call a real use case for a customer. So for anyone who's not aware, Memorial Sloan Kettering basically has what they call the CBio portal, which is an area for cancer researchers to put their data. And by leveraging things, they were already a ClickHouse user for that cancer data, like that's already where it was being stored. But they basically recreated Agent House. I'm not going to actually link to it because I don't really, like, it does cost them money to run their agent, so I would prefer the CBio portal's agent be kept relatively down the DL, so that way then we don't cost them money. But basically from there, their researchers can go ahead and ask it things about cancer genomics and treatment trajectories. I tried using it once. I do have to admit the data it spit back out of me was way too advanced for me as a non-cancer researcher, but it did seem very promising, and apparently the researchers really enjoy the fact that now they can just ask questions via the UI, and for the most part it doesn't, from what I've heard, doesn't really hallucinate because it's very bound boxed by the data, so it's actually very good about just being honest if it doesn't have it. It did spit back out at me, actually, that it didn't know something, and it told me to ask a different question, basically. But this is a really great example of a customer just taking advantage of something that, like I said, we basically built out. And so what we did next is we made this a little bit easier for the people going forward. So we have a GitHub project here called ClickHouse Agentic Data Stack. Basically what it is it's a Docker composed, it's a Docker image, basically, that will bring up LibreChat, ClickHouse, and LangFuse, which is a observability, an LLM observability tool. And basically what it does is it throws them all into one Docker container that you can just go ahead and spin up, and then you can kind of play around with it yourself and hook up your own MCP to your own data set within either ClickHouse or honestly whatever you're using. As long as it has MCP, you can go ahead and hook this up to any kind of database or any kind of data source that allows it. And basically you can go ahead and chat with it and check it out, and yeah, I think it's really great overall. So this is kind of what this looks like in total. On the backside, this is what we call the agentic data stack. This is something that we're kind of, I guess you could say, pushing forward. But you have, ClickHouse with MCP connected to LibreChat, which then the users can query from. You have LangFuse doing the LLM observability. And then you have the I like how this is basically using a magic image, the LLM model in the background doing some of the magic of the actual querying, et cetera. So I've kind of already showed this when I did the LLM.ClickHouse, but LibreChat is basically just an interface that you can connect whatever model that you'd like, whether that's also your own or an open source one or the big major ones. And basically it's very highly configurable. It's very similar, like I said, to interacting with a Claude or ChatGPT, but you can make it privately for your own projects. It doesn't have to be like out and about in the real world. And it's fully open source. You can use it wherever you like. And then we have observability with LangFuse, which I'm not really going to get into too much, but basically LangFuse is, it gets your traces from your LLM, so it can show you, for example, how much it costs to run the LLM. It can show you if there's been errors or issues. It can also do evals as well, where it does quality checks, et cetera, and prompt management. Basically, it's, like I said, a very large observability tool, and ClickHouse acquired LangFuse earlier this year, so that's why we started to kind of, this is actually a full integration because we also acquired LibreChat back in last fall. So basically this is a full integration of all of the companies that we have acquired working together to kind of like build out this image, I guess you could say. So the key takeaways for this project, and in general my talk, I feel like is, well, obviously for this one, the entire Agentic stack runs in one Docker compose up command. That's one of the benefits of this project. ClickHouse handles analytics and large-scale data needed to power the agents. MCPs give agents structured, safe SQL access without prompt engineering, which is great. You don't really have to do anything. It just automatically works. LangFuse makes every LLM call observable, which is obviously very essential for production workloads. And this pattern is model agnostic. We don't care if you use Anthropic, OpenAI, or Google. That's specifically for this project, by the way. That's like this project does expect one of those query keys. In the future, it will be also available to open source as well. We're just working on it on the engineering side. But yeah, I just want to leave this as like the final slide here, which is that you're welcome to come connect with ClickHouse. We have a Slack channel. That's the Agent Data Stack project. And then we're also here sponsoring. Some of you guys I actually recognize because you've already stopped by the booth. We just have a booth in the back corner over there if you'd like to stop by. But yeah, thank you guys so much for joining me. I was not expecting to be the first speaker, but you know, things work out as they do.
Thank you so much, Zoe, for your flexibility and being willing to be the first speaker. Do we have any questions from the audience? All right, one moment. I'll bring the microphone to you. Is it on? Yeah, oh, okay.
So do you have a process by which you implement the prompt feedback, like in a feedback loop, as in when you first roll out a product, for example, this one, you're probably working on some hypothesis and something, more than hypothesis. But how do you evolve using the prompts that are being given, or do you at all do?
So if you're talking, are you talking about Dwayne, our internal agent, or like the LLM.ClickHouse one? The internal, yeah. So with that, from what I understand, we've done a little bit of extra training on it, but so one thing to note is that by the time it was released to employees, it had already been beta tested by an internal group, I guess you could say. So most of the kinks had been worked out. But from what I've been told by the team, they don't really go back and change it too much. It seems relatively contented. I think they had to go back and change it when we had like some new business data. Like I think we had hooked up something like Salesforce or something very recently. Like they had given us basically the API or the permissions to do so. So when we hooked up Salesforce, that caused a little bit of, we had to update like the glossary, we had to update some of the other documents so that way then it understood what it was reading, and then we had to do a little bit of retraining. But for the most part, if you're not adding new data sets, you don't really have to go back, at least for us, we didn't have to go back and train it. Obviously, that probably wasn't the case during the original training period when it was in quote-unquote beta, when most of us internally at the company had no idea it was being built. That probably was not the case. I'm sure they were training it a lot as they were iterating.
Are there any other questions? All right. Well, this was very thorough. Thank you so very much, Zoe. I guess one question that I would have, and maybe this isn't particularly relevant because you said that you don't work with the data and analytics teams too terribly much, or you're not on their teams, but you said that Dwayne fundamentally changes how people interact with the data warehouse. Are you able to talk a little bit more about that?
Yeah, so from what I understand, it used to just be that people would use multiple tools to get their answers. So like if you were a salesperson, you might go to something like Salesforce, and then you would go to like a visualization that the data analytics team had built out for you to basically use as like a resource. And then you would go to another tool and another tool to maybe get the answer to certain questions. Like you were basically doing the analysis yourself of aggregating a very specific question about a customer or what they were doing or what they were using. Versus now with the internal system, we can just go ahead and ask it a question like, hey, this customer, how much have they used for storage? What are they currently paying? What are they currently doing for this? And like the agent can just go and basically build out a full portfolio for you. It can basically take all those disparate elements and even possibly sprinkle in another data set that you didn't even have access to because it was in a different tool or someone else had, permission to use it, but not you. And then it can give you greater context. So that was really where it came in, is that it was, yes, there was also a little bit of like people would come directly to, as anyone who's ever been a data analyst can attest, they would just come directly to you and ask these kind of questions, or they would be like, hey, why don't you build me this thing that allows me to just self-serve, which is just another tool when you've already probably built something that they could self-serve from. But from there, they asked a lot less questions of those people. And again, this really didn't this just allowed them to focus a little bit more on their actual work, a little bit less on focusing on the questions. And yeah, again, it took away a lot of these disparate elements and put them all in one place together, which isn't obvious for everyone. It also helps in that This is especially a great tool if you're dealing with non-technical users, because just because you have a data warehouse, it's not like you can really tell someone in sales, oh, just go query Snowflake. Like that doesn't really compute, that doesn't really work. That's not really how these things actually operate in real life. They might not know how to even write a SQL query, and it's not really their job to begin with. So that's a big empowering piece of this.
Wonderful, thank you.